we're going to take a closer look into isosceles and equilateral triangles. There's a lot of definitions in this part. So I know you guys know what an isosceles triangle is. It's, you know, a triangle with two sides that are congruent. But now we have specific vocabulary associated with that. So if we look at here, the two congruent sides are called legs. So I know that AB and BC are the legs of this isosceles triangle because those are the ones that are congruent. The angle where the legs intersect, right here, where they come together, is angle 1, and that's called my vertex angle. So the vertex angle is where those two congruent sides come together. So angle 1 is my vertex angle, and the side opposite my vertex angle, so if you literally drew an arrow, the side that it's referring to is AC, and that is called my base. That's called my base. Okay, AC is the base. And the angles along the base are called my base angles. So 2 and 3 are called base angles. Angle 2 and angle 3. Okay, so that's a lot of vocabulary in that little bitty section. But again, if you look at it without my drawings there, these are the legs. My vertex angle is what holds them together. My base angles and side AC is my base. Now, remember those if-then statements. They're never going to go away through the rest of geometry. So look at what it says. If two sides of a triangle are congruent, then the opposite angles are also congruent. So if AB is congruent to BC, then angle 2 is congruent to angle 3. That's the statement that I can say. I can also call it angle A and angle C since there's only one of them. Or I can say 2 and 3 since it's lettered out there. All right. The converse, remember we flip our if-then. So the converse is that if two angles of a triangle are congruent, if angle 2 is congruent to angle 3, then the sides opposite those angles are congruent. So then AB is congruent to BC. So we have two big theorems over here. Isosceles triangle theorem and converse of isosceles triangle theorem. Now, let's talk about how we can fill in the missing values here. I know that angle L, because these two sides are congruent, opposite angles, base angles, are also congruent. So if angle L is 68, that makes angle J 68 degrees. And what do you know about a triangle? There are 180 degrees in a triangle. So 68 and 68 is 136, and then 100 minus 136 is 44 degrees. Okay, so that's how we fill that in. Let's take a look at number 2. So here is my vertex angle, and that means that these two guys, because these legs are congruent, these opposite sides are congruent. So I know that 106 plus x, because these are the same, plus 2x equals 180. So that's how I can fill in for those missing base angles. So here I get 2x plus 106 equals 180. Subtract 106 on both sides, and I get 74. Divide x by 2, and I get x is 37 degrees. So angle C is 37 degrees, angle E is 37 degrees, and of course you can check your math to make sure that they all add up to 180. So that's how I would set my equation up. Look at number 4. How do we get this one? Well, I know it's an isosceles triangle, so opposite angles are congruent to each other. So I'm going to set my equation up that 5x plus 9 equals 8x minus 30. And here, of course, I just solve for x. So however you want to do it, I'm going to bring 8x over because I always like my variable on the left-hand side. And I get negative 3x plus 9 equals negative 30. Subtract 9. Negative 3x equals negative 39. And x, of course, equals positive 13. So in this one, I just want to find the value of each variable. X is going to equal 13. And, of course, I'm going to box my answer. I would set number 5 up the same way and solve for x. Number 6, let's look at number 6. Now this is the converse. Because base angles are congruent, opposite sides are congruent. So I know that these guys are congruent to each other. So 15x plus 7 equals 23x minus 17. And of course I can subtract 23 on both sides, 23x minus 23x, and I get negative 8x plus 7 equals negative 17. I subtract 7 on both sides, and I get negative 8x equals negative 24. And when I divide both sides by negative 8, I get x equals 3. So my value of x is 3 there. Okay. Let's go down to number 8. So now it's giving me a picture, and I have to fill it in. Or excuse me, now I have to make a picture because it's giving me these words. So I'm going to label my triangle RST. If RT is congruent to ST, and angle R is 9x plus 2, angle S is 13x minus 18, and angle T is 17x plus 1. Find x and the measure of each angles. So there's a couple of things that I could do here. I know that my base angles are going to be congruent to each other, so what might be easy for me is that since these sides are congruent, I'm just going to set these congruent to each other. 13x minus 18 equals 9x plus 2. Now, I could have, if I wanted to, added them all up to be 180 and then go back and plug in for x. But I'm just going to set it up right here because it's less steps. So I'm subtracting 9x from both sides. I get 4x minus 18 equals 2. I'm going to add 18 to both sides and divide by 4, and x equals 5. So here I can get x equals 5, and when I go back and plug in 5 for all these pieces, remember I only have to do it once. 9 times 5 is 45. 45 plus 2 is 47. So if angle R is 47, that makes angle S 47 degrees. And I know that there are 180 degrees in a triangle, so 47 plus 47 plus x equals 180. And so together, this is 94. 100 minus 94 is going to be 86 degrees. So on these, I want you to draw that picture out. That makes it easy. A lot of times I see you guys trying to do your work and do it in your head. It doesn't work in geometry. If it gives you a figure, draw it out so you can see your base angles. You have to put these steps in. All right, let's look at number 10. It gives me information, so I'm going to say WXY. WX is congruent to WY. Angle W is x plus 6. Angle X is 5x minus 12. And angle Y is 7x minus 48. So my base angles are sides opposite, so it's going to be these guys. Right here, angle X and angle Y are going to be congruent to each other. So I'm going to say 5x minus 12 equals 7x minus 48. I subtract 7x on both sides. And again, you don't need me for this. You guys can do this on your own. Add 12. Negative 2x equals negative 36. And when I divide, I get positive x equals 18. And then, of course, I go back and I fill that in. X equals 18. Yeah, x equals 18. And then when you go back and plug everything in, you can start here. 18 plus 6 is 24. So angle W is 24 degrees. And then you can complete it. These guys would make it 180. Minus 24 is 156. 156 divided by 2 is 78. I think that's 78 degrees. You may want to check my math on that, but I think that's it. All right, so that's isosceles triangle. Now, equilateral triangles, all we need to know here is that if a triangle is equilateral, if and only if, so it's a biconditional statement, it doesn't matter, biconditional, it is equal angular. So if angle A plus angle B equals angle C, then all my sides are congruent. AB equals BC, which equals AC. If AB equals BC equals AC, then angle A equals the measurement of angle A equals the measurement of angle B, which equals a measurement of angle C. So both of those read true. So on here, if you look at number 11, if AB is 9 feet, BC is 9 feet, AC is 9 feet, if this is, they're all going to be the same angles. So 60, 60, 60. Okay, so same thing. And equal angular, always your angles are going to be 60 degrees. So these sides, they're all 60. 60, 60, 60. It doesn't matter because all equal angular, they're all going to add up to 60 degrees. So that's always going to be the case here. So if you look at like 7x, if I have to solve for x and y, you know one angle degree, 7x minus 30. I know this equals 60, so 7x minus 3 equals 60. So 7x equals 63, x then equals 9. So I'm solving for 9 there. The sides are all the same. So I can set any of these guys equal to each other. So I'm going to go for what I think is easy. So I'm going to say 14y minus 59 equals 11y minus 23 because they're the same. All sides are the same. And it doesn't matter. I could set these guys equal to each other. I could set these guys equal to each other. I'm going to get the same answer. So if I subtract 11x, I get 11y minus 59 equals negative 23. Add 59 on both sides. I get 3y equals 36, and then y is 12. So x, my value is 9, and my value of y is 12. So hopefully that's pretty easy. Just more about triangles. Good luck.